Hello, my name is Max Itommel, and this is our Iowa State Industrial Engineering Design Senior Capstone Project for Zimpro's dryer optimization. Our capstone team also consists of Zach Ford, Mike Frieda, and Drew Bears. There are three main issues with Zimpro's dryer: lack of throughput, lack of automation, as well as a high amount of downtime. The dryer doesn't meet the design capacity for throughput, as well as having a lot of buildup of wet product within the system, which leads to machine downtime. In addition, the automation of the system is not detecting some failures, and that leads to even more downtime. Our objectives that we create to solve these issues are to reduce downtime by 80% in order to increase uptime by 4%, as well as make modifications to the HMI design in order to improve operator awareness in terms of the design to performance ratio, as well as the balancing index. And we also utilize this by analyzing the system by using the dryer manual and other outside research.
During the current state analysis, we found that wet product accounted for 51% of downtime this year. Excessive changeovers accounted for 28% of all changeovers, adding an additional 3.4 hours of downtime a month. 550 labor hours this year were associated with hourly manual inspections of the dryer.
4 failure modes contributed to 80% of the total downtime. Using the statistic, we want to understand how any of these failure modes could be reduced. Dryer operators rely on the HMI to give them insights about the current process conditions. We conducted interviews with the operators to understand which specific elements in the HMI help them identify these 4 modes of failure. We found that many of the elements in the HMI are not used to gather information about these 4 frequent failure modes. We also found that many of the HMI elements are duplicated across multiple HMI windows. This led us to understanding that a lot more complexity is being added into the HMI that's not directly improving its performance. We used the metric design to importance ratio to understand which specific elements were useful for the HMI operating related to detecting these failure modes and which ones weren't. For our future state design, we aim to design an addition to the HMI that would help detect and ultimately reduce one of the frequent modes of failure. We chose to target buildup as it was the most frequent mode of failure, and currently detection of buildup relied on operator intuitions or manual hourly inspections of the dryer. Our goal was to train a model that would use the HMI element values to determine whether or not buildup had occurred. To do so, we needed to compile a data set to train our model. Our dataset included 14 days of drying operations, 8 of which where buildup had occurred, and 6 where buildup did not occur. The rest of the columns in our dataset included values from the HMI elements throughout the day. We also extracted some features from our data using inferences from the operators. These inferences included that element values tended to deviate from their steady state during buildup, and that 2 particular sensors, when their difference was less than 50, buildup had often occurred. So we trained some decision tree models to help understand what elements are useful in detecting buildup, and our best model resulted in 85% accuracy, and it used 5 different sensors as well as the relationship between 2 sensors to determine if buildup had occurred. Our goal would be to incorporate this model as an alarm in the HMI for future operations.
During our analysis of the ring dryer manual and research into the system as a whole, we found that the current ring dryer was missing one major component, that being the disintegrator. While the schematic on the right shows how the disintegrator would be implemented to the system, the layout is slightly different than what Zimpro currently has. The optimal location for the disintegrator, in this case, would be the bottom elbow, where buildup is found to be most prominent. The return on investment would take about 27 months simply through downtime reduction. We've also created a standard operating procedure for each product based on data from previous runs. This should allow for quicker changeover times and overall increased throughput. Overall, we estimate an 80% reduction in downtime from our recommendations. However, this 80% does not account for any potential increase in production by implementing the disintegrator. We also estimate our HMI improvements to reduce buildup by about 36%. These improvements should also reduce the amount of manual labor required to keep the ring dryer operational. The runner position spends the majority of each shift assigned to the ring dryer, and our hope is that our improvements aid in reallocating this runner and ultimately provide value to other areas of the plant. Going forward, we suggest that Zimpro conduct additional work sampling studies to analyze the overall reduction in labor associated with the ring dryer. The table of quantitative improvements shows how downtime is reduced through better detection of buildup.